Okay. Yeah, welcome to module 2. Yay. Yeah, so for this module, we're just going into a bit more details about deep learning. Yeah, so next slide. So as pretty similar to the last few sessions. So this week's session is going to be focused on the concepts / the content. And then, so the next session in 2 weeks will be focused on the lab. So today we're just talking about some of the concepts in module 2. Okay, next slide. So today's topics, what we're going to cover today, we're mainly going to focus on multi-layer perceptron, MLP. And then we're going to go over backpropagation. And then I wanted to leave some more time for questions and discussions as well. So yeah, those can be like questions about the quiz or the lab from last module as well. And then, yeah, we can discuss any maybe confusing topics together as a group. Yeah. Okay. Okay, and just to get things started, get the ideas flowing. Because this week's, I feel like the big concept is MLP. So just try to recall what you can remember from it. And yeah, feel free to enter any keywords just to get our ideas flowing. Yep. Right, neuron, yep. That's what I had in mind as well, neurons. Neuron backpropagation, yep. Maybe just wait a few more minutes for more answers. Yeah, these two topics we're definitely going to cover. Oh, I see some questions as well. Where are the recordings posted? Yeah, I had an announcement a bit while ago. So if you kind of scroll down in the not scroll down, scroll up in the announcements channel, you should be able to see the announcement for the recording link. And it's just a link to UTMIST YouTube channel. So if you follow UTMIST YouTube channel, it's also there as well. Yeah. Yeah, matrices, math, yep. Okay. Next slide. Yeah, so I'm not gonna go into too much into the math. I'll just stay on the more conceptual side of things. So MLP is one of the most common neural networks. I think it's also one of the more simpler ones. So like some of you mentioned, it has interconnected neurons. So that's what it's composed of. And then so I put this image here because it's actually quite interesting. Like when I first learned about this kind of stuff, it's really cool how it's kind of referenced from biology. So you can see like the neuron here, and then you have the machine learning neuron on the bottom here. So neurons compute the outputs based on the inputs and the weights, and the weights will be optimized. And then you also have activation functions. We talked about this in the last few sessions as well. Activation functions. It will control like when the neuron would fire. So it's pretty similar to the biology concept, which is pretty cool. Yeah, and then about the MLP structure. So it has different layers. So input, hidden, and output, 3 different types of layers. And then you can see in the image here, the input layer is where it's the initial layer. So it takes in the input. And then you have the hidden layers. Hidden layers, the way I remember, it's not the input layer, it's not the output layer, so it's the hidden layer. So it does the meaningful computations that we talked about in the previous slide. And usually there's at least one hidden layer. So and then of course, output layer, it displays the output. That's why it's named output layer. Yep. So that's the MLP structure. I think you'll come to be familiar with this kind of diagram. Yeah. And then we also mentioned backpropagation as well. So, so this is how the weights are optimized, because that's our goal. We want to optimize our weights to predict better results. So backpropagation, it's optimize weights based on the loss, and the loss is calculated by finding the difference between your prediction and the actual target. And then, so how backpropagation works is you have the forward pass. So when you're going from the input to the output, you would calculate the error. So like how far your prediction is from the actual target. And then based on that error, then you have the backward pass, which sends the loss throughout the network. So it propagates through the network and then adjusts the weights. So that's how it's able to achieve the optimization. Yep. Yeah, so that's pretty cool. And then, oh, by the way, I forgot to mention. So I didn't go into too much of the technical, like mathy details, but if you are interested, I did add, so I'm gonna advertise the study group GitHub repo again. So if you go under additional resources, we're at module 2 right now, I've put some more links that explains more about like the math behind it and stuff like that, if you're, in case you're interested in more of the details of how the backpropagation works.
Can I just wanted to suggest something.
Yeah, for
I
sure.
found the videos in like Coursera really confusing at first.
Right, yes.
So I went to YouTube and searched up 3 Blue 1 Browns videos, who's one of like my favorite YouTubers. So
Oh,
he has a series on like neural networks, a short one that talks about backpropagation and then the calculus behind it. And those are really helpful to me. So
okay, yeah, for sure. Thank you for the suggestion. Could you also type it out in the chat? What's their channel called?
I'll send the link.
Okay, yeah, thank you. Yeah, yeah, while I was going through Coursera as well, like it went through a lot of the math, and it was quite, it's math for me, it's sometimes it's quite hard to understand. So I try to make it so that it's more on the concept side. Yeah, but like finding online articles or YouTube videos to support that would definitely helps a lot. Yeah. So
Yeah, I had another session actually. That one, that I'm not sure if they would really fit, but if you want to go really deep into the math, there's like this book called deeplearningbook.org.
oh,
Yeah, so it's like by MLP Present. It's really nice. You should. It goes into like research level depth, so it can take you from like 0 to the end of deep learning and of it.
wow.
Right.
Okay. Just gonna let me check. Let me see. Oh, cool. Yeah. Yeah, nowadays like online has tons of good resources. So yep.
Yeah.
Yeah, thank you guys so much. I can let me save those links, and then I'll add them to our repo as well. Okay. Lots of views, I see. Okay, cool. Yeah. Let me go back to the slides. Okay. Yep. And then, yeah, it was, and then while I was going through the videos, there was, I briefly mentioned this link, which I found to be very cool. Not sure if you checked it out already, but it's playground.tensorflow.org. It's pretty cool. Like, I'll just show it quickly. I found it to be very cool because like usually when I learned it from like Coursera or other platforms, like they don't really give a live demo of how it works. So this was pretty cool. I'm just gonna admit another person, and then yeah. So you can see like there's learning rates, activation that we talked about, regularization that we talked about as well last session to prevent overfitting. And then there's also different problems, classification, regression, and then there's data. You can choose the ratio. Yeah, I think we learned from like, was it the quiz? I think the ratio is like, the best ratio should be like I don't want to say this for sure. I think it's like 70% maybe. And then activation, or just to try it out. I think value is pretty common. Yeah, so like you can actually see like the data, it has two different colors representing the two classes. And then you can add different layers to it. Yeah, we talked about hidden layers, output layer, input layer. And then you can see the output. So right now without training, like the dots here are they're showing the original data, and then the background color is showing the prediction. So right now, because we haven't trained it yet, it's kind of like bluish background, so it doesn't know. But let me try this out. If you train it for epochs, yeah, you can see like the loss is reducing, and then the weights are shown, the weights are color coded as well. And you can see how it learns. And then now the background pretty much matches the data set. So that's pretty cool. And then if you want to try with a more difficult one, I think with this one is a bit harder to learn because it's more complex. But if we add more layers to increase the complexity, I think I tried it with, let's try it with this. Okay, is this a good one? Yeah, if you train it a bit more, you can gradually, yeah, you can gradually see that it predicts it better. I thought this was pretty cool, like it's interactive and it shows you visually how everything works. Yeah, so feel free to try that out. Yeah. Yeah, so that's the demo part of today's presentation. And then, to just one final question, since I think that's the other concepts part. Yeah, just one final question. Since now that we know more about MLP, just try to maybe think about what are some real world applications. Yeah, might be applicable to the future labs as well for MLP. I'll give a few minutes. I'll also try to submit something. Predictive maintenance in machines. Ooh. Okay. Autonomous driving. Okay, so I'll learn the different directions. Yeah, that could be. So, and then the second one is predicting the maintenance in machines. Climate change. Yeah. Yeah, climate change probably has a lot of data, so more data is always good for neural networks. Image recognition. Okay. Yeah, and then especially for images, I think in the more, okay. Oh, I see the chat. More like studying the history of a machine from production to breakdown. Oh, and using that to predict when it will break. Oh, cool. Okay. Yeah. So these are all pretty good examples. Like, from what I understand, like MLP is pretty good with tabular data. So if your data can be like in the tables form, it's pretty easy to learn that. So, and then I was gonna mention, since you mentioned image, is I think in the later modules we're going to be learning convolutional networks. So I think that one specifically is targeted for images. So yeah, more exciting modules to come. Yeah, okay. Yeah, so that's the that's the end of me just talking to you guys. We're gonna have some like group discussion time and question time. So if you have like honestly anything and even like quiz questions or lab questions that you still have from the last module, we can talk about that as well. Yeah. Okay, I'll stop sharing. Okay, yeah, feel free to type the answer in the chats or we can talk as a group.